Hello, everybody. Thank you for attending this session. It's an honor to be here with you virtually. I'm Joey Costoya, a senior threat researcher based in Manila. This presentation is based on the research me and my colleagues did in the past year to look into attacks against cloud platforms. I'm currently with FDR, or the Forward Looking Threat Research Team, under the Trend Micro Research umbrella. Our team's research interests falls into three main categories: e-crime, technology, and user behavior that results in these technological or social changes. For example, we have been looking at industrial IoT for the past 5 years and have already released many papers on the subject. We are also a globally distributed team, and nearly everyone works from home. Utilizing cloud computing and putting our research tools in the cloud makes the most sense for us. Our small team within FTR does technology research, but we also run the data processing infrastructure that the rest of the FTR team relies on. As a DevOps crew, we use a lot of cloud resources to do the data processing to explore new and upcoming threats. So, of course, we were interested when a few years ago we saw an uptick in attacks against cloud infrastructure. As DevOps, we realized that there are many challenges to creating secure systems, and we push ourselves to find good solutions whenever we implement anything. For that reason, we do sympathize with the victims of these attacks, but we feel that there's still more that can be done. A modern cloud infrastructure allows us to scale naturally and effortlessly, giving us the flexibility that our very uneven work patterns require. It also allows us to only pay for what we need for our current projects and not have to keep investments in hardware. Modern cloud platforms are not just some provisioned virtual machines and some block storage. We have come to appreciate the variety of services these platforms provide us with. We feel that there are few places where cloud computing can't be applied to. Gartner agrees and believes that 80%, not 100%, of IT infrastructure will move to the cloud by 2025. Still, 80% is such a huge share of computing that is moving to the cloud, such as Google Cloud Platform or the Microsoft Azure Platform or the Amazon Web Services Platform, which has nearly 150 services and counting. A simple example of how the cloud can be used is for static website hosting. One such example is in AWS, where you could leverage S3 storage to directly host the website for you. I like this approach as it avoids the security pitfalls of dynamically generating websites like SQL injection attacks, among other things. Basically, you build all of your web page files and your JavaScripts and publish them to an AWS S3 bucket that you then make publicly readable. Additionally, we can define an HTTPS endpoint on AWS Content Distribution Network, which also gives us good DDoS protection. So, what is there to go wrong? One incident that caught our attention early on was a case of crypto mining in the LA Times website. In this case, their website has a separate page dedicated to homicides in the area. But if you had loaded that homicides page in your browser, without you knowing, your browser will now start mining Monero cryptocurrency for a criminal. So what happened there? As previously mentioned, Amazon has an object storage system called Simple Storage System, more popularly known as S3. You can store any data into S3, for example, HTML, JS, and CSS files. You can also make S3 host your website content. The LA Times homicide data website is hosted directly off S3. But unfortunately for the LA Times, the attacker discovered that LA Times used the same bucket name as the domain name of the website. What made it worse is that the S3 bucket is writable by anyone. What happened there is that attackers uploaded some JavaScript based Monero miner to the writable S3 bucket. Now, the Monero miner is running on the browsers of anyone visiting the website of this S3 bucket. We sampled our datasets over a period of a month and found references to 5,600 S3 buckets. Of those, 4,400 were accessible when we attempted to verify their existence. Of these 4,400, 79 were readable, and of these 79, 40 were verified to be writable according to their access control lists or ACLs. Of course, we didn't write anything to those writable buckets because that's not ethically good. When checking if they're indeed writable, we do know that those buckets are writable because the bucket ACLs told us that they are indeed writable. Even without looking at the ACLs, there are obvious signs in those buckets that tell us that they were indeed writable. So it turns out that we don't need to test the writability of the buckets ourselves. Others have already done that for us. In this example, we see both the bug disclosure.txt and the poc.txt files in many open buckets. Whether the buckets or the contents of the bucket has been tampered with in any other way is difficult to determine. Another researcher, Robbie Wiggins, automated this task for a much longer time and inserted files in what he claims were 5,260 buckets by February 2018. This is what we don't want to see. The owner has given anyone the permission to change anything, including the ACLs themselves. In this example, we use the AWS CLI utility to examine the ACLs in a given bucket. In the case of the LA Times, the bug disclosure.txt file was dropped in the bucket much earlier than the Monero infection. However, this quote-unquote warning went unnoticed. So after some time, the JavaScript Monero miner was dropped in that bucket, and users of the site started mining for Monero coins. So do criminals only do coin miners? Not only. You could do this. You could do lots of stuff also. For example, steal user information. This slide shows that malicious code can be inserted into some website files that were hosted on writable S3 buckets. The malicious code was designed to exfiltrate sensitive information, which you can see here as encoded and obfuscated data in this slide. When decoded, you can see what kind of data that were exfiltrated. In this case, we can see that user login, email, and mailing address data are being exfiltrated off the website. Personally speaking, I do like hosting websites in AWS S3. It's simple and maintenance free, but you must do it right. You should check the permissions carefully to make sure you are granting only the bare minimum permissions needed in order to run the website. So to make sure that things don't go wrong unnoticed, don't forget to log access to the bucket and monitor for any unusual activity. Amazon has already made it difficult to create new buckets with wide open permissions, so we hope this problem will diminish in the future. In the cloud environment, computing is an even more important resource than storage is. You can see here some of the news reports highlighting weaknesses that were exploited in several computing resources deployed to the cloud. Besides virtual machines, majority of cloud computing are run using Linux containers. Containers are often thought as lightweight, virtual machines. In reality, containers are just a set of one or more processes that are isolated from the rest of the operating system. This process isolation is enforced by Linux cgroups as well as kernel namespaces. Developers love it because they can place the base operating system and all the dependencies in this virtualized, containerized environment to ensure their application will run as it was tested in the developer's machines. To run these containerized applications, you have the option to directly upload the container in a cloud virtual instance, for example, Amazon EC2. Or you could use a container orchestration platform that can run and help you scale up your containerized applications as needed. In the container orchestration space, there's Kubernetes, Apache Mesas, and Docker as the three major players. AWS also offers their own orchestration platforms, namely Elastic Container Service, Fargate, and Elastic Kubernetes Service. Now let's first take a look at Docker. We had an inkling that Docker was being exposed ways too often, so we went out looking for this sort of problems in our datasets. Over a period of 1 month, we found around 4,000 exposed Docker servers, but we are only able to verify that 45 of them are actually exposed. We most often saw XMRig or Monero minor containers running based off a few select Docker images. From what we've seen, all of these mine Monero cryptocurrency. Sometimes we see miners installed from scratch. For example, this one starts from a base Ubuntu image that includes wget and then repeatedly pulls scripts from pastebin and execute its contents. After a sequence of wgets and some base64 decoding, they already have a Monero miner running in the exposed Docker service. In case you're curious, this is an example of how an exposed Docker service looks like from a remote observer. The remote observer can see everything that is running on your exposed Docker service. If you look closely, you will see at least two really suspicious containers that are running here. Taking a closer look at the first suspicious running container, it is revealed that it is already running XMRig, which is probably now mining cryptocurrencies at the expense of the owner of this Docker instance. The second suspicious container is running a script downloaded from some IP address in the internet. These two suspicious running containers are indicative of a compromised Docker service. It was compromised because the Docker service is wide open to the internet and anyone can access it. Take note that these screenshots were taken very recently. Exposed Docker services still remains an issue today. In this particular case, we found an appeal in the code to leave the container running, with the perpetrator saying that they are only interested in mining. But this is unlikely. Similar to ransomware infections, crypto mining attacks are oftentimes the last stage of the exploitation of a cybercrime victim. And it's not true that there's no real cost to allowing crypto mining on your Docker instances. Besides the fact that they hog CPU and make your legitimate applications slow, Docker in the cloud may have some costly consequences. In AWS, for example, auto-scaling EC2 instances may make your costs explode if a crypto miner uses enough CPU to trigger the auto-scaling functionality. Since these instances will be clones of the original image, they will be just as vulnerable to infection of new crypto miners, which will lead to more autoscaling. So don't take crypto miner infections lightly. Kubernetes is also based on using containers for computation, but adds a complex management layer on top of the basics of Docker. There is an entire ecosystem that works together to make a successful Kubernetes installation. The applications are run in pods, where on top of it are layers of complex management systems that ensures uptime and enables scaling of deployed applications. The main API of Kubernetes turns out to be secure by default. Authentication to the API server is based on client-side certificates. However, the other parts of the ecosystem besides the API server are not so well secured. So that is where we see the attacks taking place. Kubelets control Kubernetes nodes. Prior to 2018, these were not secured. Port 10255 is a read-only informational port and speaks only plaintext HTTP. Port 10250 speaks HTTPS, but it only supported authentication with version 1.10 after March 2018. It's likely that not everyone has upgraded, and for those who have upgraded, they might not have enabled authentication. The problem is that even though port 10250 is secured, we can still read the configuration and extract a lot of private data about the running system from the non-secure port 10255. When we first searched for kubelets in Shodan, we found around 1,800 exposed kubelets. More recent searches will likely reveal a lower number, but is nowhere close to where it should be, which is 0. The trouble is that port 10255 already gives us a lot of insights into our application architecture. For example, by listing the pods that are running inside the Kubernetes cluster. But is it possible to infect Kubernetes with this information? Turns out, we did not need to look far and wide to see several Kubernetes installations that were already compromised. For example, this instance already have a Monero miner installed. It's pretty unlikely that the owners of this instance intentionally run this Monero miner themselves. Kubernetes also uses etcd for distributed configuration management. etcd is similar to Zookeeper, if you're familiar with that, or key value stores like Redis. etcd is the system that's used by Kubernetes to share state and configuration across the multitude of member nodes in a Kubernetes cluster. Originally, we saw 2,400 exposed etcd servers over a period of a month, though not all were associated with Kubernetes. This number might be slightly lower now if this more recent search is an indication. However, whatever the number is, they all leak data. Kubernetes stores a lot of node information in etcd. There's a lot of infrastructure information that tells us a lot about the Kubernetes cluster. Private information might be unintentionally disclosed by exposed etcd servers. This screenshot is just an excerpt of the data that you can see from a leaky etcd server. The leaked data just goes on and on and on. It goes for pages. What's worse is that certificates are also stored in etcd. So the most important lesson here is to not expose your infrastructure to the internet. We've also seen leaked cloud credentials as well as insecure software deployments. A constant theme is that the more complex the system is, the harder it is to secure. DevOps emphasizes agility and speed. It comes from the Silicon Valley mantra of quote, move fast and break things, unquote. But this is not good for security. We tend to get careless if we move fast, especially with regards to security. Moving fast and breaking security is not a good thing. But the cloud is really a great opportunity for us too. Businesses has embraced the cloud and DevOps because it fits their business needs very well. But obviously, it requires everyone to rethink how to deal with security in the cloud. Fortunately, we have the available tools that could help you in securing your cloud infrastructure. These tools might also help you manage costs by identifying inefficient usage of cloud resources. We think that criminals are still learning about cloud technology and have only been going after the low hanging fruit. If I had to guess, I'd say we'll see much more cloud specific attacks in the near future. But if we all start using the best cloud DevSecOps practices and use the mechanisms and available tools for cloud security, we should be okay. So stay vigilant and thank you for attending this presentation.